Now we're going to talk about displaying categorical data, and there's some different ways to do that. Circle graphs, also known as pie charts, bar graphs, and Pareto charts. And here's one of my favorite pie charts. Yellow is the percent of the chart that looks like Pac-Man, and this white piece is the percent of the chart that doesn't look like Pac-Man. Anyways. All right, so the circle graph or pie chart is an excellent way to compare responses for categorical data. Now, it's very important that the categories do not overlap. So respondents can only select one category. Relative frequencies, that means the relative frequencies have to add up to 100%. So if I asked you what languages you speak, and if you speak more than one, you could check off more than one, and that would be an issue. But if I asked you how many different languages you speak, you would only have one answer for that. You couldn't give me more than one, and that would be appropriate for a circle graph. Now, you can use either actual or relative frequencies, and you can label each slice or use colors in a legend, which is always nice. So in this example, Tanya asked her classmates how many pets they own. The responses are in the table, and we're going to sketch a circle graph. Now for me, I can see that the total number here is 24. So I could slice this up into 24 slices, but that's a little difficult. If this had been a smaller number, this actually might have been easier to slice up. So instead, I'm going to use relative frequencies. So 6 out of 24 is 25%. 12 out of 24 is 50%. And then I'm going to use my calculator here, and I get 16.7 and 8.3% rounded. Don't forget to put a title on your graph, which is the number of pets. And that 50% slice looks like the easiest place to start, so I'll cut it in half first. Then I'll cut out a quarter. And then I notice that one of these slices is about twice as big as the other one for this piece here. So I'm going to just kind of place it so one slice is about twice as big as the other. And you can eyeball it. These don't have to be perfect. Then go ahead and label each section, and you've made a circle graph. Now, another way to do categorical data is bar graphs, and the nice thing is they are allowed to overlap. So if I wanted to do bar graphs of the different languages you spoke, that would be okay. So they can add up to more than 100%. Now, bars, unlike on a bar graph, the bars don't touch. And the reason is there's no continuity from one category to the next, because you could have English, and what would come next? Well, it's really your choice. Could be German, could be Spanish, could be French. Whereas when we do a histogram, when we're looking at the grades and we had 59.5, okay, the number that comes next is right after 59.5. So there's a natural continuity with the histogram that we don't have with categories. Now, bars can be vertical or horizontal, and there is no specified order for the bars, like I was just saying. The histogram, there is an order, but with the bars, there's not. So here's a class of 30 students, and we asked them to check off what languages they speak, and we're going to make a bar graph. One thing you'll notice is if you look at all these responses added together, it's quite a bit more than 30. And the reason is most of our students speak English. We have one who doesn't. And then we've got a student who speaks German, 2 that speak Vietnamese, 12 that speak Spanish, and 3 that speak French. So I'm going to go ahead and start making my graph. Label the title as languages spoken, number of students for the frequency, and they go, looks like I have to go close to 30, so I'll just go ahead and go in 5s. And then I'll put the languages down underneath, pretty much in the order they're in the table. And basically I make a bar, and I'm going up to almost 30. And then there's German with 1, Vietnamese, Spanish, and French. Notice that the bars are not touching on a bar graph. Okay, now I could have put these in an order of popularity, and that type of chart is called a Pareto chart. So we list the categories in descending order of frequency. So in this case, I looked at the music that 30 students liked in the classroom, and they were allowed to like more than one. So you can see this again adds up to more than 30. So I'm going to do music genres liked and number of students, and my highest number is 15. So there we go. And I'm going to start with the most popular category first, which is pop, and then rap. And I just kind of go in descending order with K-pop being the very bottom one. Then I basically do the bars like I did before. So on a Pareto chart, you should always see this pattern of the bars kind of descending as you go to the right. Now, some things to keep in mind to avoid making graphs misleading. 3D pie charts are cool, but they distort the slices, making them appear bigger or smaller depending where they are. If you look at this here, let's say I was to kind of cut this even there, because the back piece of this burger is smaller, it makes this 33.8% seem a little large. Now, our eyes are actually pretty good at 3D, so we can kind of figure it, but still it does distort it. We want the lengths of the bars to be proportional to the frequencies they represent. And we want to have axes start at 0 if possible. Otherwise, it can make small differences look larger. And you can use this symbol to show when a scale is broken. That is where we don't start at 0. So again, here, the problem with this graph is that it's distorted because it's 3D. That looks like it's a bit more than a third. Here, the problem is you got one bucket for 19, 2 buckets for 32. They should really be proportional. Someone probably should have cut part of a bucket out. So that I wonder if the buckets are supposed to be like 20. And then on this one, it starts at 50 to 70. So it makes this one using the software look a lot better than traditional testing. So the axis is broken. They didn't use that. So it's a little misleading.